failed that year. I meant to wasn't here to play jokes. I was here for serious stuff. Did you send me the question paper?
Yeah, I sent the one for 2024 and 22.
Okay, wait. Let me do this. Stop sharing. I don't want you guys to see my chats. Let me open WhatsApp. What if you see things here? I was busy. Let's say I was busy trying to have some game, talk to a girl, and then I fumbled. So you can't see me fumbling.
I want to see you getting rejected, Baba, with that.
Hey. You can't see such things. I want you to guys to glorify me and think of me like it's the goat. So let me open this. So the thing is, like I'm tired. Man. I was tired. Look, now I feel a bit better, but I didn't get enough time to like prepare anything. So most of the things here, I'm freestyling. So let's go to the main important part. What is this thing? What is it called again? Runtime analysis for analyzing algorithms. Blah, blah, blah. Given the result or output, or give the result or output for the following binary operations. Okay, that'll be 8 divided by 2, which is 4. So do you write it in binary? Do you write 4 in binary? What? I don't know. You guys know they explained in class. Where's the part for consider the following function and use primitive counting to determine its runtime as a function of n. So you guys you didn't mention any other things. So I won't go into many things. Most of the things are on the slides, especially these parts. Yeah, these are on the slides. So let's just do the runtime analysis thing, this one. So primitive counting. Me, I'm gonna do it my way, right? But then you see the main important thing, right? We know is to get that order of, right? That big O. If it's supposed to be order of n, all of you guys should get order of n, but the calculations might be different, right? So yeah, I don't know. Did they explain in class what they mean here? Are they telling you which is are they basically listing what's valid? Like what's a valid primitive thing? Like what can we count? I think that's what they're saying here. They're saying these are the things that we can count in our algorithm. If you see this, just say +1. That's basically what they're saying here. Consider the following function and use primitive counting to determine its runtime as a function of n. The array's length the array's length with the following assumptions. Declaration is primitive. Array access is primitive. Function calls are primitive. Assignment is primitive. Expressions are primitive. Show all calculations and be sure to provide the final answer in the big O notation. So this is exactly big O of n, or order of n. It's pronounced as order of n. The technique that's being used is called big O notation. But the answer, when you write that O, you call it order of. You mention what's inside the brackets. If it's log n, you just say order of log n. If there's n inside the bracket, you say order of n. So I think this is what they mean, this part. When they say primitive, it's just listing the things that, or the assumptions that you should assume that they hold true, right? So declaration should be counted. Array access should be counted. When you're calling a function, you should count. Is it primitive? No, it's fundamental. Another word for primitive is fundamental. Did they explain this part? Maybe I'm understanding it wrong. Did they explain this? Well, what does this part mean? Did they explain in class what this part means when they say primitive, blah, blah, blah?
Yes, they did.
What did they say?
They they said well, you should count you should count them. You see the
Oh,
declaration, yeah, and
okay, yeah.
yeah, yeah,
So I'm on the right track. When you see
yes.
this, just know they're just telling you what assumptions you should have. So which makes the work easier, to be honest. Makes your lives easier. So let's do that. So first of all, what are we trying to do? What's the whole point of this? Like when they say find the runtime or whatever something, they say yeah, find its runtime. Its runtime. If you look at the word time and run, right? That means it's the time that it takes to run. So we're actually estimating. This is what we call an estimation. Remember, in mathematics, this is like I said, especially computer science module, it's mathematics. So anything that you know holds true in mathematics, you must come and apply it here. So we're looking at the time or assumption or an estimation of how long would the algorithm, right? If you check the definition of algorithm, uh, if you check the definition of algorithm, right? An algorithm is basically a clear and concise step. Is it something like that? Step by step. Um, um, is it? I don't know how to complete it, but it's like constant. It's like it's a clear and concise step by step approach, also approach to solve a specific problem, right? Or solution, right? It's a solution that's number one, clear and concise. By clear, it means and concise. Okay, clear. The clear part, it means that it's unambiguous, right? Meaning that that's what it means. It's unambiguous. So we need to estimate. Okay, kind of losing my train of thought a bit because of the noise. Just give me a minute. If I get lost, just understand. So we're trying to find how long this algorithm will run. I can demonstrate it inside code, right? I'll show you inside Eclipse how we can find the actual time, like how many seconds that code took. It's very simple. So we're gonna try to estimate how long it will take based on input size. So this will be the algorithm, as I was talking, a clear and concise step-by-step approach to solve a specific problem, right? So what problem are we trying to solve here? We are searching for a specific element in an array. So that's the problem statement, right? For those doing informatics, that's the problem statement, the thing we're trying to solve, right? So we're trying to estimate how long will it take. And we have multiple ways of estimations, right? We have big omega, we have big theta, which is maths. I think you get the idea. Comsa is maths. Big big O, right? There's no, it doesn't have another name. It's big O. So we have, if I'm not mistaken, like I said, I didn't prepare for this thing. So big data, yeah, big omega is the best case, if I'm not mistaken. It's the best case scenario, right? And then this one is the average case, meaning on average, how long does it take? But then all these values or all these things, they are not useful information, right? It doesn't really tell us how efficient an algorithm is, right? So this would be the worst case, like worst of the worst. So think the worst thing. For example, if we look at our algorithm here, and here they told you that we're trying to find yeah, big O. They told you big O, meaning we're looking for the worst case. Why are we always focusing on the worst thing? It's like we're very pessimistic, right? Like we're very negative. No, we're not trying to be negative. We're trying to estimate the maximum time. If the maximum time something would take in a worst case scenario is slightly low, that means in the best case scenario, algorithm is very fast. It's like it's almost instant, almost like not close, and just an exaggeration, like to for so that you can get the picture. Almost like a speed of light, right? It's like instant, right? So we have the worst case. We want the worst case because if if it's able to run at a very somewhat fast speed at the worst case, then we know even at the best case, it's even way better. It's way faster, right? So we have different. I want you guys to picture the result, right? In terms of graphs, because like I said, this is maths. So you need to look at it in terms of graphs. If it's a linear like this, this would be a linear one, right? It's linear. You can think, if you remember in maths, you can think of that graph, y is equals to x. Is it? Yeah. Yeah, y is equals to x. Was it? No, it's I'm thinking about our linear, no, not the one for, yeah, this one. Y is equals to x. Imagine if we drew a straight line, we have a Cartesian plane, right? We have all the four quadrants. Then we drew a straight line from from quadrant 3 to quadrant 2. Is it? I forgot the order. Is it 1, 2, 3? Yeah, yeah, from quadrant 3 to quadrant 1. Imagine we drew a straight line like that, right? So that would be a linear thing, right? That's a linear graph. I want you to picture them in terms of graphs. Then if it's n squared, it's the quadratic. Because if you look at n squared, we have that squared there. It's basically representing this formula, ax squared plus bx, if you still remember it, plus the quadratic formula. So it's then there's the logarithmic, blah, blah, blah. I think you kind of get the picture. So that's something that you should understand. And one last thing before we start, if you have, remember the formula for finding the final answer, right? It's always going to be some constant, right? It might be zero, it might be like, it might not be there, right? Or it might be there. But if it's there, you can, some constant C times the order of n, right? Most of the times the result's gonna be like this. It doesn't matter what is inside the parentheses, can be order of n squared or order of 2 to the power of n, doesn't matter. But most of the time you're gonna have that constant right there. One thing I want you to understand about that constant, in terms of runtime analysis, you can omit it. You can ignore it because it's not the main thing. For example, let's see something here. Let's look at this quadratic formula here. If I have ax squared plus bx, will this change my shape in any way? This constant plus c? No, it's not going to affect my shape of my graph. If it's increasing, it will still increase. Either way, it might increase at a slightly slower rate, for example, if I subtract, or increase at an even higher rate if I add a bigger value, but doesn't change the shape of the graph. We are still increasing. The main point is we are increasing. So that's why if you get, right, for example, the final answer is 2n. This is actually n. You neglect that 2, that constant, because it doesn't affect the graph. Even if you have 1,000, it doesn't matter. It's a constant. It doesn't affect the graph in any way whatsoever. So you omit that, or you remove that constant, and then the final answer will just be n, which is the main shape of the graph. So I'm going to open this. I'm going to say, is it Desmos? I think it's Desmos graphing. Yeah, I think that's the calculator to draw, to put an equation here, and then it draws the shape for you. So if I have, for example, y is equals to x, yeah, that straight line from quadrant 3 to quadrant 1. So you see, there's the graph, right? If this graph, right, let's say it's constant, right? Basically, you can imagine n. So imagine in this case, x is your n, right? Right, imagine x is your n. If I do this, I put a 2 here, does it change? Does it have a significant change? You see the graph, it doesn't change it. It doesn't have a significant change. We are still increasing, still going, even if it's 2,000, you see, it's still going up. We're still increasing, even if it's like, oh, it's 2,000, this is 2,000. You see, it doesn't matter how, even if it's two quintillion, it doesn't matter. The graph still increases. That's why in your final answer, you always omit the constant, because it doesn't affect the shape of the graph. the graph, unless, of which is, I've never seen that happen. Unless if the value is negative, then it actually changes the shape of the graph. But we never have a runtime. We don't, if you remember physics, whatever, you can't count, how do I put it? You can't count backwards. The same way as you can walk backwards. That's like primitive knowledge, right? That's fundamental knowledge. But then you see why we never worry about the negative, because there's no time. You can't count backwards and say, if I ask what's the time, you say it's negative 12:15. There's no such a thing. So that's why we never take into account we never get any negative values. We always positive. Because if we are able to get negative values, that means even in our runtime algorithm analysis, we would make sure that we include the constant in the final result because it can affect the shape of the graph. In this case, it will never affect it because it's always a positive value. So therefore, we always omit it. I hope that makes sense. Why we omit the constant and we just say uh, order of n instead of order of 2n, because that 2 doesn't actually change anything about the graph. Even if it's a plus 1,000, it doesn't matter. It doesn't change the graph. So we are counting because this is important. This information here is important so that all of you guys get the same answer. Because if they didn't tell you the assumptions, you're gonna come up with your own assumptions. Like I said, this doesn't matter what values you get, as long as the final result is what they expect it to be. So you get marks for mainly the final result. Then they're gonna mark for your steps, or you actually have common sense. You knew that, oh, this counts. So, but then if they told you the assumptions here, the answers need to match 100%. So let's say this is the function, right? So let's say let's do the answer, right? The answer shouldn't take too much time. They said okay, this is not a function call. Let me see. Declaration function calls are primitive. Assignment is primitive. Expressions are primitive. Expressions. Okay, that is his RX's assignment. Yeah, declaration is primitive. So here, right? If I was the one writing this, like if I was writing this, analyzing this algorithm, there's three things that are taking place here. Remember the algorithms, right? When you're coming up with the formula, when you're writing down the answer, you're looking at how many things are being executed or being run at a specific time. So you're looking at how many things are being executed or things that are happening right at that time. For example, I'm declaring, that's number one, right? That's the first thing. The second thing, number two, is I'm assigning a value to that variable. The third thing is I'm accessing this should be a static variable, right? A static, it could be it couldn't, no, it's not a static, it's an instance. Yeah, I'm accessing an instance variable called length. So I'm doing three operations here. The word operations, right? Think of it like, for example, a doctor. Remember, a doctor he operates on a person, right? So the word operation, operator, you're operating on something. So that means the main conclusion I'm trying to get to is that operation is equals to a verb, right? I'm taking you back to school now. Yeah, still back in school, but like back to like my primary day. What is a verb? A verb is a doing word. Yeah, if you still remember, this represents our actions, right? Actions. If you look at the um what's happening here, number one, declaring. The word declare is a verb, so that's why I'm going to say +1 when I'm writing my code. And then assign, to assign something. For example, your parents tells you, go and tell your younger brother, or go and assign an activity for your younger brother. See, you're going there and you're gonna tell or assign an activity, which is an action. So that'll be +1. That's an operation. That's an action. That's you're doing something there. And then to invoke, right? You're calling or invoking a variable. It's an action you're calling. For example, your parents, one of your parents calls you. That's an action. They speak to call, right? So that call is an action. So I'll say +1. So if it was in my case, if it was me and the assumptions were not there, it would be 3 for that line. But in this case, they didn't say invoking, right? Remember what we're invoking here? We're invoking a variable. And here it says, it doesn't talk about invocation of variables. It talks about invocation of functions. That's what counts. So that means I'm in my final answer, I'm gonna omit this one. So that means, so the way I usually write it, like the way I typically write it, I write the line number so that the person marking knows what's going on. So this will be line 2, right? And then the answer there is 2. I just wrote this so that you guys can know where the 2 is coming from. And then line 3. So let's check line 3. There's line 3, right? No, line 3, 4. 3, 4. And then there's line 4. We have and they said assignment is primitive, so I will count assignment. So I'm doing 2 things here, of which those 2 things are allowed: assignment and declaration. So that's 2 operations right there. So this will be 2 plus what is this one? I'm comparing, which is it is an expression, so it is primitive, so you need to count it. So this will be 1, right? Because there's one thing that I'm doing. I'm comparing ones. If it's one value is less than that value, so it's 1. So +1 plus what is this one? This one, if you're doing first year, they'll tell you, nah, it counts as 1, but this is actually 2 things here. So if you remember in code, right? If you remember Java, I++ or any language that allows this operator, I++ is basically I is equals to, or let's start here. This is basically the same as I plus or equals 1, right? Or in a longer way, is I is equals to I plus 1. So I'm doing 2 things. There's an expression here. So that counts as 1 because of the plus. There's an assignment here that counts as 2 because there's an assignment operator. And they said assignment and expressions are primitive. So this is 2. But then we're not done because this is a 4. You see the 4 keyword. This means that this will run for a specific number of times, right? So how can we find the number of times it's going to run? If you still remember something, I don't know if you still remember. You still remember I'm taking you back now. I'm jogging your memories. If you still remember that function called generate random, something like in C++, where you take an int lower, int upper, right? If you still remember that function. Remember, we first calculate a range. If you still remember that formula for calculating a range, we say upper minus lower, right? Which is this plus 1, right? So that we yeah, that's the formula. If you sit down and you calculate it, let me show you the actual formula. How did we get here? Let's say let's say I want to find the range of values from 2 to 6. How will I know the range? Meaning how many values can be generated? I can list them one by one, which is 2, 3, 4, 5, 6. That's 5 values, right? 5 numbers. But I can actually find a range by taking the maximum bound or the upper bound, subtracting by the lower bound, which gives me 4. But then this is incorrect. It's not 4 values, it's 1. It's 5. So I need to add a 1, which gives me a 5. So that's why we always add back a +1. That's what this +1 means. If you check and you play around and use different ranges, you realize that the general formula is that you take a lower upper bound and you subtract a lower bound from it, then that result you always add 1 to it because it's going to be short of 1, so that we get the actual precise or exact number of values that can be generated, or the precise range. So that's where this formula comes from. You see, I'm sure you can agree with me. So far, we are seeing maths one way, even though there's a bit of code, but there's maths one way. So yeah, you need to understand what you're doing mathematically first before you can attempt this thing. So we have this, right? What was I talking about again? No, I got lost. Okay, yeah. So we have this for loop, right? And we need to we're not yet done, because if you look at everything inside here in this loop, it's very important to understand how many times it runs. That's when you actually need to actually understand for loops and the language and things like that, of which the textbook is very important in this scenario. In a for loop, this is what we call the initialization part, and it's executed once, right? So this part over here, in this case, it's two because we have also some operator. We have another, we have also declaration here. So it's assignment and declaration. But then this part will always be a constant value because it's done once. And then this part over here and this part is done differently. It's done, oh, now my mind is coming back. It's done, I was coming back on why I was explaining this. It's coming back. I wanted us to find how many times this loop will run. You're gonna see that it's gonna run up until you see that it stops before that number. So that means if I have 6 here, it's gonna stop at 5. So that means that's my upper bound. It's gonna stop at 5, right? Which is in the general. Let me explain it a bit. If I have an upper bound, if I'm supposed to stop at 6, that for loop, it states that when I is less than that number I'm supposed to stop at. So meaning the actual number should be 5. But how do we get 5? We take that number n, which is the input size, and subtract 1. What if the input size is different? It's 7. So that means I have to stop at 6. How do we get 6? It's 7 minus 1. So the general formula is that given any input size, you subtract 1. N minus 1 is actually the exact stopping point. Or, yeah, the exact upper bound. Remember, I'm trying to calculate the range so that I found out how many times this part will execute, right? How many times? So what is the lower bound? It's 0. So I have to subtract 0. So this will be upper bound minus 0 plus that 1. If you still remember that plus 1 that we talked about here, that the formula always needs you to add that plus 1 back. Then this will just be BODMAS. So we start with what's in the brackets. In this case, there's no multiplication and things like that. So we just simply remove the brackets. Minus 0 plus 1. And then we just do simple math. Minus 1 or minus 0. Minus 0. 0 doesn't, it's nothing. 0 represents an absence of a value, right? Meaning there's nothing. Even though it says there's a minus 0, it doesn't matter, it's still 0. This cancel out, right? Minus 1 plus 1, they cancel out. So I'll be left with n minus 0, which is just n. So therefore, this loop runs n times. That's the range, n times. Since I now know it runs n times, remember we talked about the anatomy of a for loop. These two parts here, the Boolean expression part, which basically tests whether we still need to continue to enter the loop or not. Then there's the update statement, which updates our loop variable. Loop variable meaning that the variable can only exist within the loop. The moment you are out, you reach this curly brace, that I variable, the loop variable I, it no longer exists. Hence, it's called a loop variable because it's only part or belongs to that loop. So this statement here, the update statement continues getting executed as many times as this part gets executed. So that means the same, I'm going to multiply by the same value here. So I less than n, how many times are those comparisons done? As long as we are still not yet at n. So that means n times, because we did find out the range, which is n. So that means whatever value I got here, and times that by n. So I'm going to go back here, and that was a 1, so it's times n, right? And then I plus plus, that was a 2, because we have the addition and the assignment. So it's 2 operations. So that's also n. So I need to not forget to times it by n, because it's going to run n times. You might ask yourself, why am I timesing by n? This is simple maths, guys. This is very, very simple maths. If you did maths 1B, this is very simple maths. I don't have to go into details and explain why that is, why you're multiplying by n. If you think about it thoroughly, right? Let's say, let me make an example so that you guys can see. If I have, let's say the number, let me not type it down. Let me just explain by word of mouth. If this is n and we say this is 4, like the number is 4 here, we're starting at 0, right? And we're stopping at the number before 4, which is 3. So that means I'm counting from 0 to 3, inclusive of 0 and 3, which is exactly 4 times. So it's going to start at 0 and compare. Is that the case? Then goes inside the loop, then goes to the update, then compares. So if you sit down and you break that down, that process will be exactly 4 times. So that means this comparison, which is a 1 comparison, will be done 4 times. So if I was to write it like this, it will be that one comparison will be done 4 times. So that means 4. How do we get 4? It's 1 times 4, meaning the number of operations that are done times my input size. That's why we always going to multiply by n. And then we go inside the loop. This one inside the loop is very obvious because it's going to run n times, however many times the actual loop will run, because it's in the loop. Remember, as long as this condition is true, the loop will continue executing. And we have concluded that this part here, this condition over here, it runs exactly n times. So if this is a comparison, right? This is an expression, so it counts. So expressions are primitive, and we also have in that same statement an array access, meaning we are accessing an array element, as denoted by the square brackets. So this is 2 operations. We access the element first. That's the first thing that we do. We access. We go and look for the value. That's an action. You're going to look. So that's 1. Comparing, you're checking, is this greater than this? If you compare, if I give you 2 things and I say compare, don't you actually do an action? Don't you use both hands and put these things up and compare and look at them? So that's an action. So this is comparing. So it will always be an action. This is 1, and then this is 2, but then it's within a loop. So it's 2 times n. So in line 5, it will be 2 times n. That's exactly how many times it's going to run. And then they said declaration array. Yeah, they didn't mention about returning. So this part here, they didn't talk about, let me see, function calls. Yeah, they didn't talk about, it's not a function call, it's just returning a value. And here they didn't mention it. So don't count it. You see here, there was no mention of it at all. And this is not an expression. And then we exit our loop. Line 7 only has that curly brace, which just does nothing, just defines the scope. Then we've returned, which does nothing. Again, it just returns the value. And so we're done. Those are all the values, or how many times in each line that we have the operations that will be executed. So now the final answer, right, is to add up all of those values. That's it. And then that's your runtime analysis, and then pretty much done. So 2 plus 2 plus 1 times n plus 2 times n. And then, okay, I'm missing another 2 times n, which is line 5, plus 2 times n. So this is this is the equation that I have. Now I need to use, some call it PEMDAS, some call it BODMAS, some call it, is it BTMAS? In whatever way that's what we're trying, that's what we're going to use here. That's the approach you're going to use. Whatever you call it in your, wherever you were taught, that's however you call it. That's what exactly what we're doing here. We're looking at the precedence, or basically what comes first, what needs to be done first. So brackets always have a higher order. We call it order. So it have a higher order. So we're going to start with whatever's inside the brackets. So it's going to be 2 plus 2. Remember, when you're starting with whatever's in the brackets, you don't add, you don't do anything else. You only do what's in the brackets. So I'm going to rewrite it as it is. So this is 1 times n, which is just 1n. But then remember the mathematical rule that if that number is a 1, you can simply omit it. Imagine there's an invisible 1. So you need to apply that same rule. And then plus 2n. This is greater than 1, so which is 2. So we need to put the number there 2 as it is. So 2n. And then there's no multiplication or blah, blah, blah. So we don't have to worry about division, all those things. We only have addition now. They have the same precedence, meaning that I can add all of them in one go. So me, what I would do, right, the maths way, I'll start with adding the constants on their own, 4. Then I add the terms with variables, right? So n, remember there's an invisible 1 there. So that's 1 plus 2 plus 2, which is 5. So 5n, right? So this is 5n. So this is basically the final answer. So now how do you get to the conclusion of writing the final answer? So this will be order of n, right? 4 plus 5n. But this is not done. Remember the rule in coming up with the runtime analysis. You omit or you ignore all constants. So this will just be the order of 5n. Which, if you remember mathematics, see, there's a lot of maths involved here. We can put the constant outside. So this would be 5 times order of n, like this, right? So we can still omit the constant. If you remember when we started, what did I say? You always have a constant times the order of something, whether it's n or n squared or log of n. And this is exactly what you have here. There's that constant, there's the order of, right? So this will just be the order of n. So that's the final answer. So you'd have to denote all the steps. Me, I like putting line and numbers so that they know. Don't do this, right? Don't explain like me here. I was just showing you where it's coming from. Don't be explaining and doing all of that. You just put the number, like how many operations. Oh, you can. I remember you can. Technically, you can. But then this is how you can represent it. You can put 2 and then explain and say 1 is for this, 2, what the other one is for assignment. You can do that. That's up to you. But there's no need. You don't have enough time to be acting all fancy in there. So this is how you do the runtime analysis. All the other questions, I don't know. I didn't prepare. I really wouldn't know. You'd have to read the slides and also know maths and things like that. So I'll just demonstrate how to check the time. I don't know, maybe it might become important. I don't know. I'm just going to demonstrate how to represent a pair of static class. Okay, so I'm just going to demonstrate how to calculate the time for an algorithm inside code, right? Let's take that exact same code, which is this. So I'm going to open Eclipse. Excuse me. So Eclipse, I'll just show you how to calculate the actual time of the algorithm. You never know. Maybe they might say write the code because I think I don't know. I was reading a different textbook, but it was there in the textbook. I just read, just brushed through on the algorithms things. Uh, just a simple project, nothing too fancy. Runtime analysis. And then I'm gonna create a main class. Main, I don't know why it's opening there. And then I'm gonna put a main function. So there's the function, there's the class. Then all we're doing here, we have a function that takes an array and then it searches. Then we store, oh yeah. This is why even in my code, I like to do this. You see this? You may not see the difference, but then it saves you a lot of time in terms of computation. If you were to put it here, that means in every iteration, you are doing a call. You are going there to fetch it. Go fetch it. Go fetch it. Go fetch it. So if n is a million here, that means you're going to fetch a million times, which is extra necessary steps. That's why we always get the array length. We go get the length once, then we put it in a variable. Then we just only focus on comparison to save time. It's a small difference, but that difference makes it's a small change, but then that makes a huge difference. Then I'm gonna have a function here. It returns the number if it found it or -1 if it didn't find it. So it's called search. And then say it is an array, but I'll use this syntax here. It's called, what is it called again? I forgot. I'll call it ARR. And then I'll have the value that I'm planning to look for. Did I do it correctly? Let me see. The argument type int must be the last. Oh, I forgot that rule. If you're using this approach, it must be the last thing, the last parameter. Yeah, like this. And then I'm gonna have int n is equals to my array dot call the length. So when you write the syntax over here, right? This one over here, it means you can call the function in two ways. Like this, you can have search, and then you pass the value you're looking for, let's say 10. Then you can pass a whole array like this, or you can pass them separated by commas. So 1, 2, 3, 4, 5. We can do that. So that's what this means. There's two ways of calling the function. So I have this, then I'm gonna do a for loop int I is equals to 0, and then I is less than n, and then I plus plus. Then if we found the value looking for, so ARR at index I is equals to that value we're looking for, then we simply, what are I supposed to return? Is it true? Is it not the actual index or what? Or, yeah, we're supposed to return the index. And then if it didn't go well, we just return negative. If we didn't find the index, we return -1. So I wrote it in my own way. It's still fine. This is still an array. It's still fine. I just doing it this way so that I pass, when I call it, I pass those arguments. There's a formula you can use here to calculate. There's a approach to use to calculate how long the algorithm takes. So what I'll do is I'll also include this initialization part here, that call, so that I know precisely how many seconds. So there's a class called you can go inside system. So I'm gonna call it start time, meaning it returns to get the current milliseconds, right? You go to the system class dot current time what's the current time in milliseconds, and then you can just cast it to an int or a long. Should I just put a long there? Will that suffice? Yeah. So let's use a long because it's gonna be a very long number, no pun intended. And then I'm gonna have the end time. So make sure the starting time, you get the starting time. What time did it start? And then you within that you let the algorithm run. Then after the algorithm ran, you store what time it ended. Then you find the difference between those two values. So that means the actual time, I'll just call it time, is end time minus start time, right? And then to get that, to get the number, remember this returns the number in milliseconds. I want to get the actual seconds. So I'm going to divide this by 1,000. That's the formula to convert from milliseconds to seconds. Then I'm just going to output that time and say the algorithm took, okay, I don't like this. Let me use the printf function. Took percent s seconds, right? Second, or it could be 1 second or seconds in plural. So I'm just gonna put the s inside brackets. Yeah, you have to go back to English to understand that. Then okay, I put the wrong thing. Percent d there because I want to display the time. And then done. Then I call my function. So let's call the function. So let's say we're searching for the value 10. Right? And we have these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So this will be the array. So the first value always represents that parameter, and then the rest of the values represent the array. So all of these values will be stored in their own array. So you can call the function this way, or you can actually pass a literal array. That's up to you. But in this case, I'm not. So I'm just going to call it this way. And then I'm going to run it. And then it seems like it's taking, is it running? It ran too quickly, but why didn't it display? So it was supposed to display, but I don't know whether it found what it was looking for or not. It was supposed to display. Yeah, but this is how you do it. I don't know what I'm doing wrong, but everything is fine. This is how you find the current the actual number of seconds that an algorithm took. Maybe you don't want me to use the actual array. I don't know. Let me use an array, but either way, it doesn't make a difference. To be honest, it doesn't. So I'm gonna take these values here. You see that it shouldn't make any difference. So new int array, then curly braces, put the values in there. Then I have the array. Yeah, it was supposed to return nicely with no issues. Don't know why it's doing whatever it's doing. Yeah, I don't know. Oh, it's me. Common sense. When the function is that, if it found the value return, so this part actually never gets executed. So what I can do, right, to make my code display, I'm gonna say index and say initialize to 0. And then once we found it, we update index to be high. No, let's initialize to -1. So if we didn't find it, we just simply return -1. Then I just return index. And then I'm going to run it. It should now display. So the algorithm took 0 seconds. So it's a very fast operation, right? Because okay, let me do this. It's not a bad operation. Let's say we're looking for 12. Let's change this to 12. That we're looking for 12, not 10. The thing is we have a very small array. Yeah, still seconds. Oh, I can do this. I can say that time, right? and view it in milliseconds, right? Yeah, I don't know. I guess maybe it's that fast. Don't know, but seems like it's really a small task. Yeah, the array is way too small, I think, in this case. That's why it's doing that. Because it just goes one, two, blah, 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 and then it finds the thing. So it's pretty fast, but this is how you can find the time. You get the current time in milliseconds, and then it's part of the system class, and it's a static method, and then you call after you've executed the code, whatever code you're running, then you get that current time. What's the time now? So you get the time before executing, then the time after executing, so that you find the difference of exactly how many milliseconds it took. Then that's up to you to whether to convert from milliseconds to seconds and then seconds to hours and minutes. That's up to you. But this is how you can find the actual time of an algorithm. So do you guys have any questions on analyzing these algorithms, the runtime analysis? I guys still there? And I might be talking to myself. Oh, you guys are still there. Do you guys have any questions about this runtime? I think it should be straight. It should be clear now. Zoom out. Yeah, all the other questions, I think they're pretty straightforward. There's nothing too complicated about it. What is wrong with the code? Oh yeah. What's wrong with the code is line 13. Write the Java code to fix the problem. Oh, let me just see if I can answer a few questions here. Because you see, that's the thing. If you don't read the textbook, this thing will show you. You have to read the Java textbook itself first. Know Java. Because see, these questions here, it's about you understanding Java, and that's the topic generics, which is in that textbook that you guys used in ComSci 2A. So if you look at question one, right? So Q1, A. So what is wrong with the code? You passed. Let me close this. I don't want to have too many things open. And task. Okay. So if you look at this code, right, what's wrong, I can immediately see it because I have read the textbook and I understand Java. So you see, the main thing that's important, that's wrong here is the type. So here you see you're passing a primitive type. That's not allowed. This will crash. It's not gonna work. So you'd have to say that what is wrong with the code? So what's wrong is that a primitive type of int was passed for m generic box, right? M generic box, right? They said identify the problem. They didn't say identify the problem and end the solution. The solution is a separate question on its own. Oh, you can. Okay, it didn't mention, but you can offer a solution inside, and then you can say just a more, not a solution, but to explain what was actually expected. Whereas should I say wrapper? Oh, it wouldn't be accurate if I say wrapper type. Yeah, okay, yeah, it's fine. Instead of a wrapper type of int. In this case, it's a wrapper type, but it should be a class, the name of a class. That's what should be passed there is the type. in general to include everything. But in this case, we passed a primitive type. So instead, we should have passed a wrapper type of that primitive type as the type there. Then they tell you, write the Java code to fix this. So you go to that line, right? You could also mention and say, in line 13, explain that at line 13, that was the error. Then here you can explain how to or to show the code on how to fix it. It's just simply you passing the wrapper type. So you just say integer like that, and then come on, integer, and then semicolon. And then that's how you fix the code. So you pass, and you need, when you work in the generics, right, in Java, it's not allowed to pass a primitive type. It's unlike C++. C++, you pass primitive types and it works. So that's why it's important to understand the language you're using. Its inner workings is very important to understand that. So Java, you're only allowed to pass in, well, they're called a reference type. So this would have you could have used a wrapper, or you could have just said a reference type. A reference type, you don't have, that means you don't have to specify the actual type. You can just say you passed in the code, a primitive type of int was passed for mbox, for m generic box, but a wrapper or a reference type was expected. And then done, you get your full 5 marks. Let's see what this one was supposed to do, if I can answer it. Create a recursive function that does the same task as the function A called AR. Draw a recursive trace. This part, I'm out. I don't know. I forgot how the recursive thing is done, like the diagrams. I don't know about that. Discuss wildcards within the, hey. It's not gonna end well if you don't know Java. And this thing, I actually read it yesterday. I remember reading this thing exactly yesterday. So let me explain wildcards. I don't know. Since this was a 2024 paper, it might come back. There's a high chance, there's a high likelihood, like majority of these questions in this question paper will come back. Then a few ones will change. So wildcards, right, in my own way, in my own understanding, right? Let's do a diagram here. In my own understanding, right? Wildcards is sort of like it's sort of like a way to explain a range of types that can be passed, right? That's the main important thing it's sort of like to quantify, right? Yeah, I would use the word quantify. Can you please mute? Okay. Okay, if since it seems like you have a question, can you unmute and ask your question? Lutando, how can you ask?
Yes. When you're done, can you please look at question 2A when we're done with what you're going to explain now?
Oh, okay. Question 2. This was question 1. Okay. Question 2A provides pseudocode to use to implement remove first method and then remove first method. Oh, that's easy. Okay, we'll look at that once we're done. So let me continue here. I just want to explain the whole what is this? The whole no, not open, create a new diagram. The whole thing about wildcards. So you need to actually understand Java. I don't know. Let me fix this thing. It keeps on showing lower end. Keeps on showing as if you're still asking a question. So let me close that. So with wildcards, right? Let me do this. Let me search here. Box. I need a box here. So we have a box here, right? Pretty mundane, right? Pretty basic. So we have this box. With wildcards, you have the ability to specify a range of types that are acceptable, right? you can specify, it's all about, the main important thing is about the range or the quantity of types that are acceptable. So in a way, you're trying to restrict it's the way to, another way you can say is that it's a way to also offer restrictions to specific types that can be passed. But those restrictions that you're enforcing, it also specify, that means that there's a specific range that can be passed, right? It doesn't mean that it's like sort of like infinite, right? So there's two ways you can explain that. You can say where am I? Yeah. You can say that it's when they say discuss wildcards in the context of generics, yeah. In the context of generics, it's a way to, number one, quantify the types that can be passed, right? To specify that this is a specific range of types that are allowed to be passed. Number two is to restrict. Even it's somewhat these two definitions somewhat are interchangeable. Is to restrict the specific types that are allowed to be used by this generic class. So that's how I would put it. That's how I would define it, right? I hope you are writing down. I'm not gonna type that. So for example, let me make a simple example. Let's say you have animals, right? Right. I'm gonna use this person as an example, but it's still similar. Let's say you have a class called animal. You can quantify it in three ways, right? Three ways. You can use the question mark, which just simply says you can pass any animal, right? In a way, you can view it in that way, any animal. And then there's a second way that you can pass, that you can say, you can pass, you can say that you can pass any animal, but that animal should be a descendant or yeah, a descendant of this type of animal. So for example, T extends bird. So this means that I can pass any animal, but then not just any animal, an animal that extends bird, meaning I can only accept birds. So you only accept birds, right? That's in when you translate it, that's actually what it means. Then there's the third one, which is question mark super T, right? That's basically whatever that type is. Let's say super animal. So that means you are that means the type that can be used is a type that is going to be the super class for animal, meaning the parent of animal. So that means I want to deal with parents only here. Because if you say super of animal, it means that it's the super class for animal, which means it's the parent class. So that means I only want to deal with the parents. So here you can think of it in this example when there's parents meetings at school, right? When there's parents meetings at school, they say we don't want you, we want your parents, your super class. We don't want to deal with you, you're a child. You are the child, because in this case, animal is the child. So they don't want to deal with you. They want to deal with your parent, your super class. So that's what it means. So this is the three ways you can define using wildcards. So as you can see that what it's doing now, it's exactly what I've defined. If you look at this number 2 1, I say I'm telling Java that I accept any type that extends bird, meaning I only accept birds, because any type that extends birds is a bird, because remember, is a relationship. That's inheritance, is a. That means I only accept birds, only birds. So I accept animals, but only birds. That's definitely what it means there. So if you can see that it narrows down the range, if you notice. So that means I don't want anything that has to deal with the ground animals, that like your leopards, your cheetahs, your jaguars, those cats, snakes, python, anaconda. You don't need all those animals. You only need this specific type of animal, which is birds. So it narrows down the range of accepted types. So that's another definition that I would give for a wildcard. So you should provide Java source code as an example. And I did actually make an example here technically, but I didn't write it in Java. Let's write it in Java. So you're gonna have public class animal, right? To demonstrate generics in Java, after the name of the type or the name of the class, you put a less than sign followed by T and a greater than sign. So this means that it accepts some type T. We can call it T, some type. T comes from the word type. If you look at the word type and you take its first letter, it's T. So this means it takes any type or some type, right? So it's a generic class. Then I'll just make it an empty class. Then underneath it, okay, I'm not, okay, this should be one, it should be only this part. Then what I can do is I can say that I can use this second approach, the second example as the solution here. So I can say question mark, and I say the type T that you're passing, it needs to extend whatever you want to pass here, that's up to you. You can say it extends T. So in this case, it's a bit, you need to think out of the box. It's a bit complicated in this case. That means it accepts T itself, that type, let's say integer, and the integer's descendants. That's what this means, the way I wrote it. But you can write it in this way and say question mark extends animal, right? That means that type that you're going to pass needs to extend, and it needs to be a animal, right? It needs to extend this class, right? That's the other way you can do it. Or you can just put T there. I think T is fine. Don't complicate it. Just say T. So whatever type I'm passing it, it's going to be the descendant or the derived class for T. So that's the example you need to give there. So let's look at remove first method of the doubly linked list ADT, which removes the first node in the list. So if you have a doubly linked list, you need to remove the first node. Remember, you have it's a doubly, so you have previous and next, right? So you need to change those pointers and stuff, all those things. So another thing you need to understand is the functions that you need to call. So I don't know whether it's possible to go claim it now. I don't know, but you need to know this. You see this list interface. These are the methods that you use. Oh, I can actually do this and this question paper because majority of the things I know. For example, I can implement this queue. Queue is very simple using these methods. It's really straightforward. And yeah, you need to do some bit of thinking in there. I was thinking about the comparable thing, thinking about that, but it's fine. So you don't need to implement the list methods. Yeah, this is good. They'll tell you what not to do, but these are the methods that you can use. As you can see, right? Remember, most of the types that are in here, uh, I think all of them, like linked list, queues, blah blah, stacks, they all use the list interface. They implement the list interface. If you remember, they do that. So you need to make use of that. So we have also the remove method. So this is very important. You need, if they don't give you this function, the list of functions, you need to know them by head. About add after, add first, add last, search first, whether the list is empty, size, all of those things. You need to know them by head. So let's go back to question 2 now. So we need to implement this, write the source code to remove the first node, right? And it's only 6 marks because they expect you to use this. Because that time, if you remember the practical dlist, it implements the list class, the list interface. So they expect you to use those methods. You get marks for calling those methods, the right methods, right? So this is, I think this is actually very easy. Yeah, if I'm looking at the right, I don't know why it's 6 marks though. 6 marks is kind of scaring me. I don't know why it's 6 marks, because this is way too easy for 6 marks. Because why am I saying suppose you have a function called first, which returns the first node? And then you know where I'm going with this. Then you have a function called remove to remove that node. So you need to call this first node, pass it as a parameter inside the remove function. And then you're done. You've removed the node. They said the first node. Yeah, so you remove that first node. So if I remember very well, okay, a link, doubly linked list ADT, abstract data type. I didn't mention whether it was an array based, or but okay, this is a list based one. So that means inside, yeah. So that means inside, I think it's called, gonna call it what? Yeah, but inside the class, or inside of this class, we have an instance of this, if I'm not mistaken. Or we implement that, but then we have I forgot, I forgot, but this is a pretty straightforward approach. I totally forgot what's that? There's an instance variable that you must have. I forgot what data type it should be. But since it's list based, I think it's gonna be of type, yeah, that list, yeah. Yeah, it's going to be of type list ADT, yeah. I'm still trying to think about it. If it's array based, right, you're gonna have public D list, no, public class D list of type T, type T, right? But then that T that you're passing, let me think, that T that you're passing, if I'm not mistaken, you have to have something like this, extend comparable of type T, yeah. Or you can just do this. Yeah, this is where you're using the, what are they called again? The wildcards, yeah. They're using the wildcards. But then it also implements the, you don't have to write this, right? I'm just writing it so that I can have the mental image of what's really going on. It implements the list ADT, right? Which is type T, right? Implements that, and then there's gonna be the class. In your practical, I think it was like this. Then what was it also extended the marker interface called clonable to clone, if I'm not mistaken, your guy's practical. Yeah, I think it was like that. And then here have we have what? I forgot. There was a lot of code in that practical. I just forgot what that's called. Let's just I forgot the data type for the data type. So I'm just gonna call it list, right? I have my list in there. I forgot the data type. In this scenario, I don't think it's important. What's important is to delete, I think. Let me see. Yeah, to implement the remove first method. So you need to basically create that. So the only thing that you need to create, don't create this whole class, right? Don't do that. I'm just doing it so that I can have a mental image of what's really going on. So you just have to write it this way. So it's public. And since it removes the element, it most likely going to return the element that it has removed. So public T, right? Meaning that's the what's going to return. It's going to return that element, which is of type T. And then it's called remove first. It should take an element, right? I don't think it takes a node. Yeah, it's not node based. Remember, it should take an element, that number to remove. Yeah, so just say list. Don't come up with, don't try to think about the data type. I forgot. It was straightforward when you have the source code. But now when I try to implement it on my own, I forgot what it's called. So let's look at the functions. We have functions like first, which returns the first node. And it returns the node, right? If you look at it, what is it? It returns a node, if I'm not mistaken. Yeah, a node. But in this class, we do not want to associate this class with anything to a node. So I don't want you to ever do spiritual things and you have node of type T here. Don't ever do that. Don't. You see things like this? Yeah, don't do that. We're trying to get the first node, right? Which is that element that you want to do, that node, right? So it's we want to get that first node and delete that first node. So there's a first method which returns the first node. And they said we should delete that node, right? Which removes the first node in the list. Yeah, so that's exactly what it should do. So for me, this will be very easy. I'll just say return, right? And list dot remove, right? Remember, there's a lot of assumptions here. They're going to assume that this is your double linked list. That's you don't have to make it extra. That's why I said you don't declare this whole class. This question is not worth 15 marks. It's worth 6. If it was worth like 20 marks, then maybe they want maybe a bit of a section of a class, then a few methods and things like that. But in this case, they don't. So I'm using the list variable, right? Which represents the D list, which is part of this class, which is going to have access to those methods, right? If I'm not mistaken, this should be it implements this. It has to be iList. Yeah, it implements iList. Then this part of it has to be related to iList in some way. Yeah, it has to be related to iList in some way. Or maybe stack based. I don't know. Forgot what those different kinds of ways to implement it. So we would need to do that first node. If you look at this function, remove, it returns something of type T, which is that element that was removed. So that's why I'm retaining that a call to that function, because the call to that function returns a value that was removed. If you look at this practical, if you look at the question here, it says to implement the remove first method of the type. Oh, yeah, they want you to know. So yeah, you have to know that the remove first function should return. They didn't tell you, so you have to know. I think that's where the other rest of the 6 part of the marks out of 6 is you understanding that the function should return that element that was removed. So I'm going to return it. So that's why I'm returning a call to this function, because a call to that function returns the element. Then now the question is I need to pass the element or the node, not the element, the node to remove. So what's the node that I need to pass there? It's the first node. So I need to go to list again and say list dot first, which gets the first node. So it starts here, get the first node and return it. That node that was the first node that I got that was returned, it was now passed to remove function, which returns the element that was removed, of which that's what the function expects you to return. This is incorrect. Yeah, let me think. Yeah, this is incorrect. I didn't fin I didn't finish reading the textbook. I think this is the syntax, but I was almost done the generics part. Just revising. I'm human. I forget these things sometimes. I think this is the right syntax. Yeah, you don't just put T there. Yeah, you don't. Yeah, you don't put T. Yeah, right. Don't just put T there. You must put it inside brackets, because if you remember here, which is, yeah, it's actually, you can now, I think you should understand it. You see here, we didn't put a T on its own. We put it inside bracket, those greater than, less than symbols. So same applies here when you're declaring the function. So this will be the full answer. This will get you a full 6 marks. The first 3 marks is for the function signature. For example, you understand that it needs to be parameterized, that T. Then the name of the function is correct. Then the parameter, what does it pass? So that should be 1 mark, 1 mark, 1 mark, so 3 marks. And then here, I don't know how they're gonna do it, but they're gonna find a way to calculate it. So for example, 1 mark for passing the first node, maybe a mark for calling the remove method, and then a mark for returning that node that was removed. So gives you 6 marks. So do you guys understand?
Yeah.
Okay. So
Yes.
for this one over here, the queue, yeah, I'm not gonna have time for that. There's a lot to you don't need to implement the that uses the list interface. Yeah, I don't have time to be implementing this whole thing. It's gonna take a very long time. Then we have what are they called? Pop, top. I don't know. There's those different function names. You just need to find a way to use these functions to achieve this. When I look at it now, this was very easy. When I think about it now, this was a very easy question. This is a free marks over here. Literally free marks. If you just understand the formula, you don't need to cram code here. You must understand what a queue is, how it operates, the methods that are part of a queue, and then you're done. That's it. You're done with, if you have enough practice, Java. That's easy. You're done. You know how to use the word keyword implements. Or to use an interface, you implement it. Use the keyword implements. So this was definitely not a hard question. Maybe the other ones they could be. Consider Java array of type T. Write a stack, a class. It's not looking good for you guys. This thing, for me, I could finish it in like, how many minutes is this? Because it should be 1 minute per mark. Yeah, 1 minute per mark. So I would finish it in like 20. The maximum time I would have is 20 minutes, right? So probably if I obviously I'd have practice revised, yeah, maybe less than plus or minus 10 minutes for both questions. Because it's straightforward once you practice. If you're doing a practicals and everything, this is easy, straightforward. The only problem you're gonna have, you should have is anything that says T, or if it's code, you should be like, it's easy. I did practicals, I know that. What is the runtime of each methods defined in the previous question? So if you don't know these methods, that means you also lose that next 5 marks. Done. It's chai for you. Stack, I think it is push method to push into the stack, and then pop to remove from the stack, and then top, which returns the top of the stack without removing that element at the top. Those are the 3 main important functions: push, pop, top. Yeah, then you're gonna have things like they said an array here. You're gonna have your things like, what is this? Your constructors and blah blah. Yeah, and then you're done. And then for Q, I forgot. Oh yeah, Q is NQ, DQ. Yeah, those are the words you should use, which is exactly the same as a stack, but different order. So you'd have to use either add first a lot of times or add last a lot of times to get the stack or the queue, depending on the formula. So for a queue, it's first in, first out, right? FIFO or FIFO if you're African. We say FIFO, but it's pronounced as FIFO. So FIFO, that means first come, first serve, right? So if I'm inserting in the queue, I would want to put it as the last node because it's gonna queue up. So I would have to use, for queue, you have to use the add last method. You technically can use the add first method, but you'd have to understand what you're doing. For example, if you're adding first, that means the last node is the first person in the queue. So that means you have to, and there's no function to find the last node, to return the last node. There's no last function here. You are not given. If you were, then yeah. In this case, you're not given. So you can't use add first method. You can only use add last for the solution of for this question here. That's the only one you can use. You have to use add last. So that you call the first method to get the first person in the queue. And then this one, they didn't give you an interface. I'm not sure the complete implementation of list. I'm not sure if it has the last method. If I'm mistaken, did it have for stacks? I'm not sure. If it didn't have, okay, let's see. If it didn't have add first, yeah, you have to call add first. For stack, you have to call add first method. I'm picturing it in my head, the insertion. So you're gonna Yeah, it's always gonna, if you add first, that means it's always gonna be pushed to the front, meaning that'll be the top of the stack. So that means the first element will be, yeah. So you can actually use the same interface, this one. Like I said, you need to know the right method. You're always gonna use an add first method for a stack. You're gonna use an add last method for a queue. And then there you go, I've given you the formula. And then for queue, you're gonna have nq function, right? Nq function and dq function. In a stack, we call this push, right? And then in a stack, we call this pop. Simple. You don't have to cram and cram and cram. You don't have to do that. Understand what you're solving. Done. I don't know for both classes if it has top method. I'm not sure. You'd have to double check on the textbook. If they did tell you. I'm not sure whether stack is the one with the top or Q is the one at the top or both. But it should have, I think both should have top, which just gets the top. No, I think only the stack is top. This one is called something else. Maybe first. Yeah, I think it's called first. You just double check in the textbook. They write the right names for it because there's marks for the right names. For example, if you do spiritual things like you swap them around, for a Q you say push. There's no hope for you. The problem, they might even give you zero there. That means you're confused. You're a confused student, you're a confused person. You don't know where they are coming or going. So zero. They won't even waste their time. Provide a complete Java class that realizes an array list ADT. Array list should implement the array list interface below and use the incremental strategy. Yeah, they said remember they talked about there's what is it called? There's the doubling strategy and the incremental strategy. Starting to remember it now. The incremental, right? Do you know what the incremental does? Right? Remember, this is related to when you have a array list class, right? So when they say implement an array list, right? So type T, an array list class, right? Based on an array. So that means this array list, this class, right, should be able to resize itself. So the problem if the size is big, so we're gonna have an array here. That's the array. But if we try to add, remember we're gonna have an add method, right, which adds some specific element to the array list. We can try to, okay, let me do this public class. No, me doing spiritual things now. Void, and then it adds that element, right? So before you add the element, inside of this class, you're gonna have two variables, right? Int capacity and then int size. Capacity just view it as the maximum number of elements allowed to be stored. And then size means that current number of elements stored. Basically, how many values we have currently in the array. That's size. So you're gonna have to come here and do a check. They said implement this, so I'm actually writing some of the code to implement. There's a lot of code. If you're not doing practicals, position ADT child me. I still remember this. I forgot when I was in the venue. Totally forgot about that. Clueless day. 5 marks was gone there. But the rest I was able to kind of attempt some of them. So you're gonna say if size, meaning the current number of elements that I have, you don't want to do this, right? You don't want to, you can, there's two ways. You can say if it's currently equals to, but then if I say it's equals to, that means it only work, this code will only execute only when the size is equal to the capacity. I want it to also work when the size is also greater than the capacity. So that means I need to say greater than or equals to capacity. When one of these conditions is true, right? Like one of the things, remember this greater than or equals to, remember how I'm reading it. That's why I'm saying one of them, because the way I'm reading it, what's that word? I ran out of English bundles. I forgot what that word is. But it's basically, it leads to that explanation, because if you say greater or, you see the word that I'm trying to emphasize, the key word I'm trying to emphasize is or. Remember, or works when at least one of them is true. So I want when at least one of them is true. When it's equal, meaning that I'm trying to insert when the current size of number of elements, which is size, has reached the maximum capacity of the array, which means that I can't insert it anymore, right? I can't insert into the array. So I would have to resize. So this is now resizing. But then when I resize, remember what's gonna happen when I resize. Okay, you can, to be honest, let me think. Yeah, you can, yeah, it's fine. You can also leave it as this. I was thinking about it, you can leave it as that, but they like to view it in this way, right? But then it will never, if you think about it logically, if you picture this thing, it will never reach a point where it's greater than. Because when it's equal to capacity, we resize capacity, we give capacity a new size. And they said you should use a what? Incremental strategy. So that means you increment it by a specific value called C. In this case, they gave you C as 10. So that means I'm going to do this. I'm going to create a new array. So T new array, right? Because I need a new array with a bigger size. Remember, arrays are fixed sized, right? They're fixed sized array. That's what they are calling their full name is fixed sized. If you know English very well, fixed size means it's constant. It cannot be changed. So that's why I'm creating a new array. Then I copy all the other values from that array to this new array. So yeah, I still remember I was reading the textbook about arrays, blah, blah, blah. I still remember a cute, nice way to copy the arrays without typing your own code. So there's a function you can call. So you're gonna say new array and then initialize it to new int, give it a different capacity now. But before, well, I'm just gonna set it to capacity. Then before doing that, I update capacity. So update capacity. They said incremental. So that means you should initialize capacity to a increment by a specific value. Usually we increment by 1, but in this case they told you, so it's always class C, some constant. C in this case just means constant. The constant that they told you to use is 10. So here you're gonna say 10, right? 10, that's what's the value you need to use. If you don't use this 10, you start deducting marks. So before using the capacity, so that means every time when the size is at least equal to capacity, resize it, resize the array. Then what you're going to do is you're going to copy elements from one array to another. The question is, how do you do that? It's easy. You can do for loops, right? Yeah, blah blah, copy, keep track of where you currently are. All those things you can do that, right? But that's not really necessary because in Java there's a function for it. You go inside system and use array copy. Is it array copy of? I forgot. Let me check the textbook. Is it array copy of? It's array something. Um, it's array copy of. Yeah, it is. I think in full there's the array copy of. Uh, Textbook is thick, but once you read it, you realize how much valuable information it has. Okay, single arrays, copying arrays. Where is it? No, array copy. It's just array. The off is not there. It's array copy. Okay. So I want an array, a copy of the array, right? So the parameters so I want to copy from one array to another. So how do you do it, right? So you have source arrays. You pass the source array, right? First, then you pass the starting index of source array. then you pass the destination array, then you pass the index, start index of the destination array, then you pass basically how many items or elements you want to copy. In this case, you're always going to pass the length, which is the new, or which is the old, okay, the old length, because the array we're copying from is a source array, of which it still has the old size or the old length, right? So let me delete that. So that's the formula. That's how you copy. So I have that. If you're using if you're coding, you wouldn't have any problems. Remember, there's documentation in each IDE. So even if you forgot, as long as you remember the name that, oh, it's array copy, starts with array copy. Even if it's not array copy off, you can realize, oh, the off is not there. In this case, I'm using Notepad++, so it's kind of challenging. So I have the old array, which is this one over here. It's called array. Then comma, the starting index. Start at the beginning at 0 of this array. And then the array that I want to copy to, which is the new array, which is a new bigger size. Copy that new array. And then where do I want to start copying into this new array? I want to start copying into the new array from the beginning of the new array, which is at index 0. How many elements do I want to copy? This is where you need to use your critical thinking skills. This if statement here, it was true because size was equal to capacity. I cannot use capacity in this sense because capacity was updated. So I'm going to have an inaccurate number of elements that are stored in this array. So this is how it is going to work. If size was, let's say, for example, there was there's currently 5 numbers, and then capacity was also 5, because it only be true when it's at least equal to size. When these two things are at least equal, or size is greater. Yeah, of which it's impossible. Like I said, you can just omit this and just say is equals to, because it will never be the case that size is greater than. They're just writing it. If you check the code, they just write it like that. But then me, I like to be precise. So you just say it's equals to. When they're equal, then I should resize. So when it resizes, that means this will be 5. Its current size is 5. Then we add 10, that constant that we were told to add. So it's 10. Then it becomes now 15, right? So now if there's a new capacity or new maximum, you can store 15 numbers. But our array is still of size 5, right? Our array is still, in our array, there's still like 5 elements, right? So if the maximum number of elements in the array is still 5, in this case, the size, because remember, we now resized capacity. But remember, this if statement became true when both of them were equal. So that means I can use them interchangeably. I can use capacity value or size value. In this case, I can't use capacity because at this point in time, I resized it, I changed it. But I still have the actual accurate value of this array size, which is 5, and which is 5 numbers that are there. So that means you're going to use the size variable, not capacity, when you're specifying how many values you want to copy. So you're going to come here and use size. If you use capacity, it's going to be 15. Then you're going to have an error called array index out of bounds exception, which means that the array, you try to access an index that's outside of the bounds of an array. So it will throw this exception if you use capacity, because capacity is a different value. Remember, the array size has only 5 elements. And if you say you want to copy 15 elements, that's incorrect, because there's only 5. So that means when it gets to index 4, and then you try to access index 5, of which is non-existent, it crashes. So that's why I'm going to use size here. I pass size here because that's the accurate value of how many numbers are there in the array. So now I've copied the values from my old array into my new array. Then what I'm going to do is I'm going to do this. Remember, let me see, size. Let me think. Size. No, size. Yeah, my code is a bit incorrect. It's a bit. Let me think. Size is basically how many elements are being currently stored, right? Which is fine. So that means you need to understand the indexes also. You see indexes, be very careful. Size stores how many they are, how many numbers have been added into the array. You can't use that size to index. You have to subtract by 1 if you're trying to index or do things like that. So since if there's 5 elements, that means the maximum index is 4. You need to know code here. I don't want to lie to you. You need to understand how code works, for loops, everything. You need to know what you're doing here. It's the little details that can cause your code to crash. So that means if I have 5 elements, that means I'm starting from index 0, 1, 2, 3, 4. That means the maximum is 4, which I can find by saying size minus 1. So that means the maximum index is size minus 1, even though the number of elements is size, meaning 5. But the index, when I'm trying to index, right? Remember, we want to insert this new element. I need to be very careful with the indexes. So but then remember now my array size is bigger now. It's now 15, meaning that it can store 15 numbers, meaning the maximum index is now 14. But then the maximum index currently is size minus 1. Oh, not the maximum index. The largest index with an actual element or a value is size minus 1, which is 4. So I want to store after that. So that means I want to say plus 1, right? Which just cancels out, right? Minus 1 plus 1 is just 0. So this just cancels out just size. So that's why I'm going to come here and say new array, go to index size and insert that element. So insert element, right? And then I'm pretty much done. Let me think. Am I done? No, you're not done. Yeah, you're not done. Remember, in this case, I used the size variable in a sneaky way to add the new element. But the current number of elements that are there in the array is no longer 5. It's now 6. So I need to update size. So size plus plus. And then done. That's how you do the add method. I think the main hard function here was add, because that's what you need to resize. Then that's up to you. You can do this. You can put this in its own function called grow array. They like doing that. So you can put this in its own function called grow array, then call the grow array here. So this will be just replaced by a call to grow array, meaning make the array bigger, grow it. Then in the other then in that implementation part for the grow function, you have all of this statements. So I hope it makes sense. So that's how you can partially implement that. And you're using the incremental strategy. If it was the doubling, right, they would have probably used epsilon. Probably no, not epsilon. Is it epsilon? Is it what's that number? I forgot. It's in the textbook. They talked about hmm, epsilon or u. No, it can be. It can no. It can. Yeah, it can be. No, golden ratio. Yeah, it's a number. It's a number that's closer to the golden ratio. That's the number you multiply by, which is 1 point. I think the golden ratio is like 1.6 something. So the maximum, the number that the maximum number that we can use, or Java uses, is 1.5, which is pretty darn close to the golden ratio, which is 1.6 something. So if you told you to use the doubling approach, you'd have to say times 1.5. But then if you understand, like I said, this goes back to understanding the basics that you guys always try to avoid. This returns a double. This is an integer. So casting is needed here. If you don't put that casting, subtracting marks, just know they don't play around, they subtract marks. So you have to convert this back to an integer because this is an integer. Remember the processors of a computer, right? Processors basically you can view them as like those people or those things in your computer that are responsible for doing things like tasks. For example, addition, arithmetic, all those things. We have I don't know, I think I read that. Yeah, I think I read the Java textbook like twice, something like that. especially the beginning parts. So I still kind of remember some of the things. There's the ALU. Yeah, it's called ALU, right? Which has the A standing for the arithmetic part, meaning about what is addition, subtraction, division, all those things. That's the part in your computer that does the math. Then we have the logical unit, or the logic part for if statements, your booleans, whatever. So the arithmetic part, right? The processor has rules. Your processor can only allow arithmetic expressions consisting of things of the same type. So in simple terms, your processor has a part in its you can say a processor is like a machine. It is a machine that does something, and it uses its own machines to do things. Imagine its machines only allows, when you're doing addition, to add a double with another double. That's why casting was invented to begin with, because it only adds things of the same type. But if it sees things that are different types, for example, if you have a double and an int, it can promote, right? We call that implicit casting, meaning that it's done for you, it's implicit. Or another word for implicit, indirect. So you don't even see it happening. So you might assume it's not even happening. So if it sees one of them is different, it promotes that other one to promotion. That means you're going to a bigger level, right? Why am I using the word promotion? Because this is a 64-bit value plus a 32-bit value. So int obviously is the smaller one here. It needs to be promoted so that it can be 64-bit, meaning that I'm adding two of the same types, two of the same things. So the processor, the way I view it, right, the way I want you to understand it, why does it choose this approach? Yeah, you have to go ask the electrical engineers, those brilliant minds who make the parts for the computer. You have to ask them why they chose that approach. They can give you a better detailed explanation, but me, the way I want to explain it is in a simple way. Think of it as like when you go into Pick and Pay. When you go to Pick and Pay and you see containers for Stay Soft, for milk, for what is it, cooking oil, you see them, they're separated, right? Oil is on its own. Stay Soft is on its own. You don't buy one container whereby 1/3 of the container it is Stay Soft, 2/3 of the container is cooking oil, the remainder it is milk. You've never seen such a container, right? Because you shouldn't mix things that don't belong together. Like Mariah once said, we belong together. So the computer listened to Mariah Carey when she said we belong together. So it only wants things that belong together. Double and a double, int and an int. So if it sees at least one of them is bigger than the other, it promotes the other one to be the same size. I know you might be like, yeah, but what if I have an int and the float and the short? These are both integers, right? Well, like I said, the computer doesn't work, the processor to be exact, it doesn't work that way. It's gonna promote the short to be an int, so that you have an int plus an int. But by the promotion, right, it just treats it that way. It doesn't mean that this variable is now changed its data type to int. No, you would have to go change it manually. That's not how it works. It just promotes it for that short time to find the answer. Then it gives you back the answer. That's it. So I think that should be fine. I think that's it. Do you guys have any questions before or shift elements, right? Shift elements left. This is a straightforward. You just shift or you may assume. Oh, so you must use these functions. Yeah, there's a lot of thinking here. You must think. Here you must think here. There's no time to play around. Do you guys understand what it did so far?
Yes.
And then Lutando, do you understand?
Yes, I do.
Okay, which is good. I'm exhausted. I think let me just stop recording. I think that's it. I'm tired now. I guess good luck.